Hi, this lesson is going to be on how to solve square root equations. This is part 1, easier cases. We're going to have another lesson later, which is going to be on part 2, when you have more complicated cases. So, when you only have one radical sign in an equation that has a square root in it, then you are going to follow the next procedure. Step 1, you're going to isolate the square root if needed. Sometimes it's already by itself. That means leave it by itself. It has to be alone on one of the sides of the equation. After that, you're going to square both sides. Then you're going to check. Then you're going to solve the resulting equation depending on what type of an equation that is. And then you're going to check your solution. I want to make sure you understand this is an extremely important step. I will demonstrate to you what's going to happen. Okay, so let's take a look at the first equation. It's already separated. Square root is by itself. So what we do is we square both sides. And that's going to give us square root of x squared is going to give us x. 4 is squared is 16. So the question here, is this correct? If you take square root of 16, does that equal 4? The answer is yes. So that is the correct answer. Let's move on to the next problem. Square root is by itself. Everything else is on the other side. We can square. When you square the square root, it's just going to cancel each other. So x minus 3 is going to equal 5 squared, which is 25. We have one step involved. It's going to give us x equals 28. I'm going to put a question mark because we want to check. Let's make sure I write check here. So we're going to check this answer. And what do we have? We have square root of 28 minus 3. Does that equal 5? Square root of 28 minus 3 is 25. Square root of 25 is 5. This is true. This is the correct answer. Okay. Same thing here. The square root is by itself. Equals the number is on the other side. We can go ahead and square both sides. That's going to give you 4 minus 2x. On this side we're going to get 6 squared, which is 36. Subtract 4. Negative 2x equals 32. Divide by negative 2. X equals negative 16. Check. Got square root of 4 minus 2 times negative 16. Does that equal 6? So it's square root of 4. Negative 2 times negative 16 is plus 32. This is square root of 36 equals 6. This is correct. Let's take a look at this next problem. So this is the first time we run into a problem where the square root is not alone. We have square root of x minus 5, and then we also have plus 3. So we got to get rid of that. We're going to subtract 3 on both sides. So we're going to have square root of x minus 5 equals negative 1. So square root is by itself. I want to put a star here because we will come back to it. I am going to square both sides. Square root of x minus 5 squared gives us x minus 5. This side is going to give us negative 1. I'm sorry, positive 1, because you square negative 1 is positive 1. X equals, you add 5 to both sides, x equals 6. Let's check in the original equation. So the square root of 6 minus 5 plus 3, does that equal 2? 6 minus 5 is 1. Square root of 1 is 3. Doesn't sound right. So this value that we got, 6, does not actually work in the original equation. And we're going to have to reject it since it's the only number. This is what we call an extraneous solution. Okay, which means it's a solution that we obtain through following the proper steps, but it doesn't check out once you try that in the original equation. We're going to have to reject it. The answer here is no solution, or we just or you write it as an empty set. Okay, so that's very important. Now I do want to go back to what I left here and I put a star next to it. When you get an equation like that, take a good look. This is the square root here. The square root, which is non-negative value, is going to equal to a negative value. That's not possible. You could have stopped right there and you could have said that the answer is going to be no solution because this cannot possibly be. Okay, there's nothing wrong with continuing that, but you're going to save yourself time when you run into problems like this. Let's move on. Example 5. So now we have to, we also have this number here and we're going to have to add it. We're going to get the square root of 3x plus 1 equals 8. So at this point we are going to have square root alone, which completes the first step. And now we're going to have to square both sides. Okay, so what do we have? We have 3x plus 1 on this side. This side is going to be 64. Well, we solve this. 3x equals 63 and divide by 3x equals 21. Does that work? We're going to have a square root of 3 times 21 plus 1 minus 5. Does that equal 3? 3 times 21 is 63, plus 1 is 64, so square root of 64 minus 5 equals 3. Don't know yet. 8 minus 5 equals 3. This is correct. 21 is our solution. Now we're going to get into more interesting cases because sometimes you run into problems where there is a variable under the square root and also not under the square root. Example 6, the equation is already good to go for squaring because the square root is alone. That's not going to change anything that we're going to do that could potentially change the type of an equation we're going to have to deal with. So we'll square that. We're going to have 3x minus 2 equals x squared. This is going to end up being a quadratic equation. So when we solve quadratic equation, we're going to move all the terms on one side. I always recommend to my students keep x squared positive. It's a lot easier to work with that, if possible. So we're going to move these two terms here. We're going to subtract 3x, we're going to add 2, we're going to subtract 3x, we're going to add 2. Then it's going to give us x squared minus 3x plus 2 equals 0. This equation can be factored. It's going to give you x minus 2, x minus 1 equals 0. X equals 2 or x equals 1. So the question now is, do they both work? That means you have to check them both. So let's go ahead and start with 2. Doesn't matter which one you do first. Square root of 3 times 2 minus 2 equals 2. Is that true? This is 6 minus 2. That is 4. Square root of 4 equals 2. That is actually correct. What about 1? Square root of 3 times 1 minus 2 equals 1. Is that true? 3 times 1 is 3, minus 2 is 1, square root of 1 is 1. Yes, they're both good. 2 and 1 in any order. Next one. Good to go. The variable, the square root is alone. We are going to square both sides. You're going to have 3x plus 4 equals x squared. Again, it looks like a quadratic equation. We're going to have to subtract these two terms here to get 0. Our resulting equation is going to be x squared minus 3x minus 4 equals 0. This one can be solved by factoring. X minus 4 times x plus 1 equals 0. And we're going to get x equals 4 or x equals negative 1. Now we need to check those. So let's start with 4. Check. We're going to have square root of 3 times 4 plus 4 equals 4. Maybe. 3 times 4 is 12. 12 plus 4 is 16. Square root of 16 is 4. That is correct. Negative 1. I'm going to remind you what happened just a little bit a while ago in another problem. I'm going to set this up, but I'm actually not going to proceed with mathematics here because a square root cannot equal a negative number. This is an extraneous solution. We are going to reject that. Our only solution here is 4. This is the reason why you must check your solutions. You cannot just assume that they are all going to be good and you can go ahead and just use that just because you solved an equation. This one is ready to go. You have the square root alone. So we're going to square both sides. Please note that here you're going to have to square a binomial, which means you have to expand it properly. 3x plus 67 equals, this is going to give you x squared minus 2x plus 1. So we got to move these two terms here. When you do that, you're going to get x squared minus 5x minus 66 equals 0. This one can be solved by factoring also. That's going to give us x minus 11 times x plus 6, which is going to give us 11, and the other one is going to give us negative 6. So we need to check them now. Let's start with 11. So with 11 we're going to have square root of 3 times 11 plus 67 equals 11 minus 1. So let's see, this is, let's do that. This is 33 plus 67, which is 100. And the square root of 100 is 10, and you got 10 on this side. This is correct. Negative 6. Do not just assume because the number is negative you're going to have a problem. You actually need to check it. Square root of 3 times negative 6 plus 67 equals negative 6 minus 1. We do have a problem. This value here is negative. And doesn't matter what it is, it's not going to equal that because that's not negative. So what do? This is going to be extraneous. And we reject that and we only use 11. Moving on. So in problem 9 you have a square root and then another number here. You do need to get rid of that number. So we're going to have to add 4 to both sides. It's going to give you square root of x plus 10 equals x plus 4. Now we can square both sides because now the square root is by itself. And that's going to give us x plus 10 equals x. Again, binomial, you got to square it properly. X squared plus 8x plus 16. The resulting quadratic equation is going to be x squared plus 7x plus 6 equals 0. It's x squared. The factors as x plus 6 times x plus 1 equals 0. It's going to give us two solutions. It's going to be negative 6 here, and this one's going to give us negative 1. We need to check them. Let's start with negative 6. So negative 6 square root of negative 6 plus 10 minus 4 equals negative 6. Well, we don't know yet because there's something else here. Square root of 4 minus 4 equals negative 6. This is 2 minus 4 equals negative 6. This is not correct. So that's not going to work, negative 6. How about negative 1? Now we have negative 1 plus 10 minus 4 equals negative 1. Don't know yet. What do we have here? Square root of 9 minus 4 equals negative 1. Square root of 9, that's 3. 3 minus 4 equals negative 1. And this is actually correct. Right? Because negative 3 minus 4 is negative 1, and that's exactly what we have. So negative 1 is a solution. The only solution. This one's extraneous. You can't use that one. Alright, our last example is, this one should go pretty fast because we have a square root alone, and this on the other side we're going to square. Get negative 9x minus 20 equals x squared. Move these two terms so that x squared remains with a positive coefficient. X squared plus 9x plus 20 equals 0. This one also factors. You're going to have x plus 4 times x plus 5 equals 0, and we have -4, and we have x equals -5. But here's the thing, I hope you already see it. If I substitute this into this equation, I don't actually care what is going to happen on over here, because here I'm going to have a negative value. They're both negative, and whatever you get here is going to be positive. They're both extraneous, right? And our solution here is going to be no solution. Okay, and that concludes our lesson. I hope this was helpful.